That's tomorrow? No, juniors are Wednesday, right? Then it's
Juniors and seniors are the same day. No, instead of 11 to 12. Yeah, but the same day. I'm kind of excited that we're seeing this problem. He's giving them a lot more than yeah. Really? Okay, I don't think we'll get all this done.
okay.
Well, you had from over here. Yeah. No, I thought it was just, oh, what, is it really? Oh, I thought it was the summer one later, but I knew it was later. Oh, really? I thought it was the summer. It usually is probably survey. Oh, yeah. Like we can come in the hall. We don't run it. Jimmy's like at the booth. Well, I don't get like, is there like specific parents that like are elected? Everyone like has to. Or like all the parents are like, hey guys.
Okay, so. All right, so we'll get started. Can you guys all have your homework out, please, from last time? We're just going to go over it real quick here. And by show of hands, how many of you guys are not going to be on Thursday? Okay, so pretty much like past. What's up? Six Flags trip.
Oh, yeah.
Today you'll be needing a graphing calculator. So by show of hands, who needs one of them? Okay, so 1, 2, and that's it. All right. Well, yep. Yes. Yes, of course. Oh.
I would like pizza. Oh, I'm bad at public. She's bad at public.
All right, so if you guys could just have your homework out, please. We will go over these 6 problems, or actually 7. And for all of these questions for 1 through 4, what I'm asking you to do is describe if each of these situations describe a survey, experiment, or an observational study. Remember, surveys just to kind of like ask you a question, just to get it some sort of an opinion. Experiment, you're imposing a treatment. An observational study is like you're pretty much like observing a data or statistics that was already put in place. And based on that, you're able to make some sort of a conclusion or what we call the correlations, yes? So number 1, school. A group of high school students is randomly selected and asked to complete the form shown. So do you agree with the new lunch rule? So you're basically sending this out to all the students out there. What is this mostly related to out of those 3 options that we have, Kevin? Survey. Okay, there's no treatment involved. There's nothing that you're observing. You're actually interacting with your subject and said, okay, so you're asking them questions just to get an opinions out of it. Number 1 would be a survey. An advertising company wants to test a new logo design. They randomly select 20 participants and watch them discuss the logo. Tony, I saw your hands up before. Observational study, right? You're just watching them discuss the logo. So you're watching them from a distance, not asking them questions about anything. You just selected the sampling, of course, but there's nothing else that you did other than just watching them. A literacy group wants to determine whether high school students that participate in a recent national reading program had higher standardized test scores than high school students that did not participate in the program here. Now, this one may be a little tricky, but literacy group wants to determine whether high school students that participate in a recent national reading program have higher standardized test scores than high school students that did not participate in the program. Okay, Kira? Observational study, right? So you just saw the results of the students who took the test. You're not the one who imposed the test on them, so it's not an experiment. Okay, and it's not a survey, right? It's not like you're asking them a question and say like, what did you get on your test? You observed what their data showed. So it's going to be an observational study. Last one, the research department of a retail company plans to conduct a study to determine whether a dye used on a new T-shirt will begin fading before 50 washes. Amelia? Experiment. Now, I know it didn't really say, you know, divide into two groups, control group, treatment group, blah, blah, blah. But you want to test to see if this new dye product will begin fading before 50 washes. So you actually will have to some sort of, you know, do some experiment with this. You need to impose a treatment of what using the dye and all that good stuff and just really see the results. So these are the answers that you should get for your homework. Determine whether each survey question is biased or unbiased. If biased, explain your reasoning. So this one is what we did on the Kahoot, right? Which student council candidates platform do you support? So if I ask you this type of question, okay, I think this one's a little bit just kind of too straightforward, but Paulina, can you help me with number 5? Unbiased. There's not that much information to call it bias at this point. Like, what type of group are you referring to when you're asking this question? And yeah, I don't think there's going to be any bias for this one. How long have you lived at your current address? I don't know if these are actually supposed to be the question here, but number 6, did you guys all say unbiased too? Yeah, there's really no reason for this to be biased here. Number 7, I feel like this might be biased. A car manufacturer wants to determine what the demand in the U.S. is for hybrid vehicles. Very applicable to current era. State the objective of the survey. Suggest the population and write 2 unbiased survey questions. So this one, it's a little bit different from what I'm actually asking you to do. So objective of the survey. Jamie, what is the objective of the survey here? Perfect. And suggest the population. Drivers who have their licenses, okay. Who have license over 18. So car manufacturer wants to determine what demand in the US. So United States drivers, okay, United States drivers or United States citizens will not be really applicable because we're really talking about drivers. Yeah, that should be the population. And write 2 unbiased survey for question. Can you give me one of those, please? Would you like to drive a hybrid cars? And then you would just pretty like yes, no, maybe. Yep. Would you like to drive hybrid vehicles? Like, you know, 1, 2, 3, like the options that we had for this one. We can say like agree, disagree, or I don't care. Another way that you guys can do it, it's really up to this context, right? You're just trying to get the opinions out of the people. And yeah, these are really good ways to do this, conduct a survey. And we understand the population. My extra question to you, Jamie, would be, I know this is a little bit extra. How would you be able to do the sampling method for this one? Like, how would you be able to sample this one? Like from the current population? Yeah. There's so many ways in which you can do this. So it's like off the top of your head, let's say that this is the population and you want to get the survey done. How would you be able to get how would you be able to get a sample for this one? Driver's license do have numbers on them, but based on states a little bit different from state to state. Like New Jersey driver license, New Mexico driver license, it's all sort of different, but.
Well, because I was gonna say like choose every person who has like driver's license number ends in like a 2.
Ends in like a 2? Yeah. Ends in a particular digit. That's certainly a way. You go to a DMV for every 50 states, and then I say randomly select a couple of them, randomly select. You know, it's based on their last names, based on their maybe the the license plate numbers based on their address, whatever it may be. We want to make sure that we create an unbiased opinions. We don't want to just select the people from New Jersey because we are talking about the United States. You know, just eliminate all the type of biases out there so we can get the general idea of how the entire United States drivers think about the hybrid vehicles. Most likely by the time when you guys start driving in your college in the later years, more hybrid cars will be available in the market, I think. All right, so number 7, these are the homework questions. Really, number 5 and 6 were just, was a fluke. Let's go to today's lesson that I wanted to talk to you about. And again, I know that these quite recently, we kind of ended the lesson early. I don't think it will take the entire time to talk about correlation coefficients for like the next 40 minutes or so. So this is the main thing that I want you guys to understand. And before we begin this, I need you to have also your calculator out if you have one with you. Liz, do you need one? Okay. I am actually out with, do I have actual? Can you actually use your laptop calculator then, if you don't mind? Yeah, so New Jersey NJSLA practice test, and you get the calculator.
Mr. Kim.
Yes.
Julia can't join the Zoom because like her computer's not turning on.
Okay, thank you for letting me know. So in the meantime, could you guys all just write down the definition for correlation coefficients? They are used in statistics to measure how strong a relationship is. This is pretty much the main gist of what this definition is about. And the value of R is between -1 to +1. This is super duper important. And right out of the gate on the next slide, what I'm going to ask you to do is type in all these data points into your calculator. And we've done this before, but I know that we need a little bit of a refresher on how to get to that. Is everyone okay with me moving on? Yes? Okay. So we're going to go to here. All right. So this is a classic example of a data statistics that I probably mentioned to you before. Hours studied versus test scores, okay? Now, if you just plainly just look at the numbers, we can see that as hours studied increased, the average test scores for a given particular class just increased, okay? Now, of course, this may not be accurate, but we can see as one increases, the other one increases. Hence, we are looking for something called a positive relationship because both of them are going up. Now, the list 1, list 2, list 3, the way that we get to this phase is, let me first open up my computer here. Right. All right, so we go to NJSLA practice test, science test, math, algebra 2, the unit test 2. That's the calculator section, and I'll be able to have my calculator here. All right, so here what we want to do is we want to go to stat, okay? Stat button is right here, okay? Press on that, and then you press edit, and then you'll be able to get to the list 1, list 2, list 3, and all these good stuff here, okay? What I would like for you guys to do is take a look at this number on the hours studied. The hours studied is your first variable, and you're going to type in these numbers. So you're going to type in 1, 2, 2, 3, 3.5, 4, 4, 5, 5.5. I think that's the last one. Yes. So you're pretty much taking 9 students' test scores, and asking them how many hours did you study last night, and that's the general idea of what we got. So there are a couple of multiple points that we get, like two of the students studied the same hours, maybe they studied together, I don't know, but we want to put those test scores on the next column. So 65, 80, 73. Oh, it's my fault. 73, 82, 81, 87, 90, 88, and 92. Okay, so it should match up perfectly with the 5.5. Hopefully everyone is at this stage here. Now, what we want to do is we want to conduct a test, and I want to visually show you by something called stat plot on this y is equal to button. And we're going to be able to get what we call a scatter plot of all these points, okay? To actually be able to conduct a data and do a little test, we need to make sure that our diagnostic test is on. And the way that we do this is we all just press on the calculator second mode, and then we will be able to go back to the home screen. Okay, so second, you press second mode, which allows you to quit the applications of whatever you're working at. Okay, and then now what we're going to do is, we've never done this before, press second and then press 0 for me, allows us to go to the catalog section. Okay, so press second 0. And it shows you all of these different things. If you guys press x to the -1, which allows you to take a look at the letter D, I believe, if you press on that. Okay, so we want to go straight to the letter D here. We don't want to keep on scrolling down all those A, B's, and C's. And then you keep on scrolling down until there's something called a diagnostic on. You want to make sure that this is turned on for the calculator, allowing it to understand that, oh, I need to do some sort of a statistics test. You press enter. You press enter one more time, and this must be set done. And then we can actually do the statistics test. Is anyone lost right now? Yes. Where should?
It's still on A.
Okay, so press second catalog, right?
Yeah.
Can you please press this right here? It goes straight to D for you once you press this, because it's letter D.
Oh, yeah.
Yeah, and then you keep on scrolling down until you're able to find out the diagnostic test on. This. Press enter one more time. Okay? All right, so we have to be able to see this before we do any sort of test right now. Okay, so the next thing that what we're gonna do, okay, so this is what we wanted to, what we want to get to, and I want to first show you guys how to do something called a stat plot here. For some of you guys who actually had an issue with like graphing calculators, that's because your scatter plot was turned on. Can we all please press second y is equal to, and then this is supposed to show up here. Okay, I'm sorry, I cannot zoom in any further than that, because if I do, then the calculator will disappear. Okay, so you press second, then you press y is equal to. Where's y equal to? Y is equal to is the top left corner of the top left corner button. And then you have these stat plots. You want to go to number 1, and then you're going to turn that on, please. Okay, you're going to turn that on. And then the X list will be list 1s. Okay, that's pretty good. And the Y list will be list 2. Just leave it as it is. Color blue, mark is this little square button. All of these should be fine. They're all default setting. And then now if you guys press graph, which is what we're going to do now, nothing will show up. Okay, and that is perfectly fine, because if you go back to your statistics, look at your X and Y values that you have. Your X's are only from 1 through 5.5, and your Y values are only from, they're from 65 to 92. They're pretty big. They're pretty large for the Y values. And of course, your graph only goes up to +10, so it doesn't show that. So we need to take a look at the data and statistics carefully, and then we'll go to our window setting. We've all done this before for our trig graphs, right? Okay, it was really annoying to change the window settings, but we want to make sure that it's appropriate for every graphs that we do. So if you guys could just follow along with me, for Xmin, please turn that into 0. And why don't we change x max to 6? Because the highest max that we're going to get up to is only 5.5 anyhow. X scale is 1. That's perfectly fine. Y min, let's also turn that into a 0 because there's no negative numbers for the test scores. And Y max out of 100 full points, okay? That's a test score. So this is an appropriate test setting, the scale setting for this particular test. And now please press graph, and you get these scatter plots right here. Okay. Those are the data and statistics that we get. Of course, if you imagine if I take all of you guys, 25 students and then 26 students, I'm sorry, put it on there. We can see that generally, as more hours studied, the higher the test scores will be. And you guys can all see that. This is a positive relationship. You can see from the top all the way to the left-hand side, whoever studied this many hours, they're only able to about this much score. But for the students at the higher end, they generally got a better score. Okay, so what we want to do now, okay, so this is a scatter plot that we just sketched. We want to find out something called a best line of fit. In statistics, in like Microsoft Excel, and even like in SATs and standardized tests, even the real world statistics, we want to be able to predict, okay, based on the data that we're given. So what if the student actually studied like 6 hours, 7 hours, or maybe even 10 hours? Based on this trend, what can we expect out of that, right? So because a lot of jobs out there, we want to be able to project what's going to happen in the future. And the more accurate you are, the higher they will pay you for it. So for this particular test, we're going to be doing something called a linear regression. And here's what we're going to do. We're going to go back to statistics, please. Let's go back to the button right there. And there, if you scroll one to the right here that says calc, this is this screen right here. Okay. If you press on number 4, it says linear regression. That is what we want to do. We want to find out the best line of fit. It's called a line for a reason. AX plus B, MX plus B, same thing. So that's the linear function of what we're going to do. So then they're asking you to input a couple of things. X list is list 1. Y list is list 2. Frequency list, store regression equation. For this one, I think what you could do is you can go to variables. Okay, I think actually I want you guys to do this. Go to variables and then go to Y variables, function, and then Y1. So for store regression equation, you want to make sure that that says Y1. And I'm going to show you that one more time. Go to variables here, which is this button. Go scroll Y1, and then function. And then we can store that in Y sub 1. And then that allows me to have the equation already input into the Y is equal to 2 in the first place. So there's nothing extra that I need to do. And if you guys are ready with that, just please press calculate. I'm just going to still be on the screen for those of you guys who are still. Anyone lost? Yep.
Yeah, when I click like 4 to go to like Y or whatever, it doesn't bring me to that page. It just like puts it up on the calculator.
Let me be over there. Okay, yeah, so that's unfortunately what you have to do then is you have to copy this 5.4x plus 64 onto Y. So go to Y because it's actually 5.4x plus 64.
Mr. Kim?
Yep.
Can you help me?
Yes.
Oh, I'll take a little help too.
Okay.
How do I get the Y1?
So store regression variables.
Wait. How do you get store regression?
You go frequency list, you don't need anything. So variables. Y variables. Function. Y1. Yes.
Well, with my answer earlier,
Yeah.
what was the T versus?
Do you mind if I use it? There you go. So now it shows you everything. Now you can scroll through and right through it.
Yeah, I was trying to like, make L2 and I was
Yeah, that one, I'm a little iffy about. That's it. But now that everything's reset, it should be good.
Okay, thank
All right. Okay. So if you guys press calculate, okay. Maybe I need to do this one more time. Linear regression, list 1, list 2, store regression equation into the y sub 1, and I press calculate. And then what it's going to tell me, okay, guys, this is super important right here. The R squared, the R values, that is the thing that we just talked about. The R is what we call a coefficient of the correlation, okay? And they also give you an equation, 5.4 for my slope and 64 for my y-intercept. If you guys go up onto the graph, they actually plotted that line for you because we've already stored that equation. I know it doesn't say 5.4, but for the calculators, it's for, I guess the more accurate measurement would be 5.399999, and then x plus 64. And so that is what we call a best line of fit. Of course, it's impossible for you to draw a line that goes through all the points, but it goes through the middle of as much as possible within those given the data points. Okay, so this is how we are able to calculate the linear regression model and the equation. And from the stats, I keep on losing that page, but if I press calculate one more time, this value right here, the R is equal to 0.922. This is a measurement of how related the two things are. You see how it's about 0.9, okay? And remember from your notes that the correlation coefficient is anywhere between -1 to a +1. If you're looking at a number and it's very close to being 1, generally what we want to say is anywhere between from 0.7 to 0.99, because it's really hard to get like a perfect 1 for correlation coefficient. We say that this has a very strong correlation with each other. So, and you can see from also the picture of the graph, you know, the more hours studied, the higher the test scores will be. So this shows there's a very strong relationship with these two, or better yet, there's a very strong positive relationship with these two entities or variables here. So this is the definition of a positive correlation. This is the one that we just did. I'm going to show you an example of a negative correlation in a moment. If X and Y have a positive, strong linear relationship correlation, R is close to being +1. Okay. So an R value, what's going on? Okay. An R value of exactly +1 indicates a perfect positive fit. Positive values indicate a relationship between X and Y variables such that as values for X increases, the values for Y also increase. So they both have a direct relationship. One goes up, the other goes down, and it's very, very related to the line, okay? So the correlation, the relationship of how close those dots are, okay? So you get these dots, and how are they close to the actual line of best fit? That is a measurement of R. As the dots are a lot closer to the line, then we have a strong, very much stronger value for the positive correlation coefficient, okay? But we generally want to say about 0.7 to 0.99. We say that it's a very strong relationship. Okay. I know that I've thrown you a lot of this calculator stuff at you, and I went through from the cover to cover, okay? For the negative correlation question, what I would like for you to do is I would like for you to try this on your own here. And I'm going to come around and make sure you guys are all doing okay. Obviously, for negative correlation, R is going to be close to being -1. So we're going to be taking a look at that. I'm going to go back to the slide here in a moment so that you guys can copy this down. But here is what I would like for you to do. Start all over again. We're going to scratch from the top. We're going to, take away all the data points out from the previous one. And let's take a look at this one. As the age increases, the average heart rate for a particular person will start to decrease. We can see that from our data statistics. Now, I'm not sure how accurate this would be, but we can see that this is going to have some sort of a negative correlation. Yeah?
When you're typing in the numbers on the list, how do you clear the bottom?
Delete. It's clear it's not going to do a thing. We want to go to a delete button, which is right next to mode. Press this on that little cursor. Yep.
We have to like reset the whole calculator before we start.
No, we can just go to step. We can go to edit, and then we can just override it. 20.
You make that bigger so you can
You mean this thing?
Yeah.
Much better, right? All right, so 20, 25, you know, you could just override it by just typing it on top of it.
Then will that clear like the linear regression thing too?
Yeah, well, that you have to kind of go back to stat plot, and then it would completely change the list 1 and list 2 automatically. And then when you go to test to get that equation stored in, it will automatically reset the setting for you. So you don't have to worry about that. The only thing you have to manually change is this. To clear stuff in the list, please press delete, not the clear button. So if I keep on pressing delete, it erases everything for me. Guys, also the one thing that I forgot to mention, you're manually changing your windows. Remember, the window has to be very appropriate to what you're actually plotting. Look at your X values. You're going from 20 to 50. So maybe you could make those into your X values, but you know, always start from 0 for X min. So maybe from 0 to 60, I guess, just to cover everything. And for Y min, Y max, make it appropriate for the heart rate. So lowest 100, highest 150. Because we really don't want to use the data points actually that's on the window setting that's actually on the table. So from 100 to 150 for X min and Y min and Y max, 0 to like, I don't know, 60. Yep.
So I got like the actual like the blocks for it.
Yeah.
But my mind from the last station.
So you want to change, you got to change that, right? So you got to go to stat, you got to do calc one more time. You got to do linear regression and then, you know, do that one more time and then press enter.
Are we gonna do that test with that begins with D or whatever?
Yes, you have to do that one more time.
What is that? What is that?
That's the stat, calc, and this is linear regression test.
No, like you know the thing where it was like D. We gotta do like
D?
X1 minus.
Oh, do you mean this one? X1 minus?
Remember we had to press that X minus 1 button to get down to D.
Oh, yes. That one, it's already, you turned it on. So you turn the switch once, you don't have to turn it on again. Yeah. That is what you should get. I mean, this is what, like really gonna be close to big negative 1. Almost all the dots, well, they kind of all go through the line here, so.
That's because you were probably. How I got it, I don't know. I just pressed the one.
are we doing here?
Not great.
All right,
I don't even know what I'm doing. I
So
got
this
it.
one, this is what you do, right?
Yeah, I know.
Okay, so let's start from there. Because and then now we're going to do some more change your windows. See, your windows are all over the place. We want to make sure that our windows is very appropriate to what you have put right here. So think of this, think of a good window setting that you could use from between this to this number that includes all of these numbers. 0 to 70, right? So 0 to 7, type in 0. And then press 7. Great. So now let's go back to this thing, and then let's take a look at the y values, okay? When you think of two numbers that actually appropriately measures all of these, like, you know, I mean, has all those numbers in between. Perfect. So why don't we just do y min to be 100 and y max to be 150.
Yeah, like sure.
Okay. So now guess what? If you press graph, I guess you didn't turn your step plot on. Okay. So press second y is equal to that's the step plot. So drag. Let's show one more time. Yeah, there you go. Press 1. Turn that on. Now press graph. Yay! There are your points right there. So now what we want to do is we want to draw a line that goes through the best line. We want to plot the best line fit. What is that? Go to cap. Go to number 4, which is linear regression. Press enter. This one, this two, they're all perfect. The only thing I'm going to ask you to do is scroll down 3 more times. 1, 2, 3. There you go. Press variables, which is right left clear. Scroll right 1. Functions. Right 1. Go down 1. Calculate. And boom, you have this, right? Press graph. Look at that.
That's like pretty good looking.
That's pretty good looking, right? So now, what it does is it actually stores that value in there for you. The only thing the thing I don't like is the fact that you probably did not turn on your diagnostics on.
Probably not.
Okay, you have to turn this on here always. Okay. Okay. The reason for that is because if you go to stat, you count. And then, well, I'm gonna just do it one more time. Calculate. It measures these R values for you. If you don't have the diagnostic it's like very close to the one right now. So that's our negative one. That shows you a very strong negative one. That's a lot of steps, I know, but you know, you gotta practice that. Okay?
I'll just like write it down in the back of my calculator.
Just keep on practicing with this, yeah. Right on the back. How are you doing so far? That was like the next max is way too big. Oh, you swapped them up. Zero should be exponent and fast. Because
So this Miss Oates person really thinking that people like took out votes just so they can like
swap them up.
Oh, you guys are doing that.
Alright, so let's go to the Windows
My
settings.
teacher said that we're not doing it.
So you go to Windows, you see how all of these are just not because you go back to settings and there will be that's your X, okay? You want to set up your Windows so that X is contained, like 20 to 50. There you go. See, that's what you want to see right there. So think of two number intervals that is good and contains all of these numbers. Just these. So 20 to 50, that's good. You know how I told you not to use it. So 15 to 55.
Charge on the phone book. I didn't remember to take it.
Yep.
Like seriously, it was like no, I paid like $5
The maximum value for
like in every time.
Right? So let's go back to setting and then the second value will be the representation. Now that contains all these. 110, 110. So I go to left, and then I go to Y, 110.
Hey, you want your book?
And then 1. Right, now press graph. Yep. Alright, so now you have the perfect graph. See, now you want to draw a line. And you should have both. How you doing? Yes, perfect. Okay, great. Then you have your you have the graph. Why is it doing that? Okay, so
every single
regression. Oh, because you literally physically have to type this up in here.
Oh, yeah. I don't know if I put it in wrong. It's
Where's your pass?
you know the one that No, how'd it go? How'd it go?
There you go.
Pretty.
Well done. All right, so
I like when you kind of
what you want to do is you want to measure the correlation coefficient. Okay, now I went through every single one of you guys, and if some of you guys are still struggling with this, that's fine, but just write down the data and change the windows. There's a lot of steps. I get it. The only way that I'm going to tell you right now is I'm going to give you just practices after practices and making sure you get the steps down. For every single one of these statistics, you want to have the window settings appropriately set so that you can see the scatter plot shown on your calculator. For this one, we have from 20 to 50. So I got my X min and X max to be from 0 to 60 right here. You don't want to, on the real world statistics, you really don't want to see all the other quadrants other than the first quadrant. Because age, time, whatever, we're not going to get a negative data for our statistics in the real world, not often. So 0 to 60 is appropriate. And this one, I made it from 100 to 150. That appropriately has all the data between all of these, why is this not working? Between these values from 115 to 135 for the target heart rate. And then you press the stats, you do calc, linear regression. List 1, list 2, store regression equation into the y variable 1. And then when you press calculate, look, look at the R value. It's negative 0.99 and 9. That's being very close to being negative 1. And on the graph, it also shows there's practically no distance from that line to the data points. They're very close to being one another, and they're not deviating away so much. So this is really like a perfect linear relationship. In a real world, that is not really bound to happen, but this is just an example, okay? So from this, we can conclude that there is a strong negative correlation between age and the target heart rate. That's what you will say as a part of a conclusion, okay? So for this one, based on all the statistics in the data, strong negative correlation between X and Y. That's what you would say for this type of data points here. Okay, so what can you conclude from this? This is what I'm looking for. Okay, so for negative correlation, any questions about this one? Okay, so this is a definition page once again. Positive and negative correlations we talked about. The no correlation is if the R is close to being 0. Okay, so that is when you have a data and statistics where if this is your scatter plot and I have a bunch of these dots that looks like this, okay, that shows no positive correlation, no negative correlation. It's more like if I were to draw a straight line, that's the best line of it will more likely go like this, right? So, and then the dots are kind of like, they're very far from being from the line. And this shows that there is really a no relationship with those two whatsoever. Okay, to give you a better accurate measurement of like the picture here. Okay, so this kind of sums it up of what I wanted to talk to you about today. We have talked about the strong positive correlation where the dots are really close to being the line, as well as a strong negative correlation. The dots are also being very close to being the line. The one that we really haven't talked about is the weak positive correlation. Notice how they generally do go upwards. Like they go from left to right. You know, we have the rising motion, but the dots are so far from the best line of fit that we call this the weak positive correlation. And if I give you a data point like that, your R values will be very weak. This is a weak or weaker negative correlation. Okay, the dots are all over the place. Moderate negative correlation, we really don't say moderate in like that. I just say strong or weak, or at least for me, that's all I care about. And this is practically no correlations. I mean, there's honestly like nothing you can conclude from this data and statistics here. Okay. All right, so I think this is the last thing I'm going to ask you to do. Please plot this on your graphing calculator one last time, and then that's going to be it for today. So we're going to measure the number of miles House is from school and their test scores. That's 12. Yeah. Oh, okay. So
Yo, wait, I got it now. Mr. Kim, I have a question.
yes.
I got to like
Mhm.
here. I just don't know where to go next.
Did you get the data points?
Yeah, I got the points. I just don't know like remember from here to get the number.
Go to stat,
Okay,
go to calc,
got it.
and then number 4.
Number 4.
Yep. And then when you go to number 4, make sure you store a regression equation by using variables.
Yeah,
Yep, variable, score, right one, and then the first one.
variable function.
Variable, y is equal to function, y1. Yep,
Okay, and I just miscalculated.
press calculate. Yep, do you see a line on your,
Oh wait.
go to graph afterwards.
Can you help me with this?
Yes, of course.
I feel like I just need to write down the steps that I keep forgetting. Can you read them to me?
Yes, okay, so first you change your, so the very first thing is go to stat, edit, and you put the value in. Yeah. So the way to delete this, you can just keep on pressing delete like this, and then you're gonna put in all the numbers. And then let's say that you did that, right? The second step will be to go to the windows and changing the window setting appropriately. Then if you press, you don't have to write this down, but if you press graph, you'll be able to see the data. Okay? Now after that, what you want to do is you want to draw the best line fit. The best line fit comes from stat, calc, scroll right one, and then linear regression, AX plus B. This one, this two, just leave it there, and then frequency list, nope. Store regression equation, you press variables. Okay, and then you go down, you go to y variables function, and then y. Okay, and then it will store the setting like the equation like that for you already. By the way, super important before you do all this, you press second stat plot. This must be turned. Second, y equal to that. The first plot has to be turned. Okay, and then that's it.
Okay, what about the thing with the die?
Second 0, which is parallel. And then on the top right, it already says A, which means you already pressed the alpha button. Press X -1. You go to B, which you scroll down to diagnostics test, which allows you to calculate the R. And that has to be on. Not all the time, but the very least.
Can I do both these things in the before the
Yes.
No, thank you.
Okay, so due to time, I'm just going to show you guys what's expected of you guys. I've already put all, oh, no, I didn't do that yet. So 12, 3, 3, 4, let's do this real quick. 8, 10, 1. 85, 72, 98. Well, 72, 98, 97, 82, 73, 68, 75. All right, so X-Men, I can make it from 0 to 15. Y-Man, I could make it from, what's the good score here? It's 50 to 100, I guess. And then if I press graph right now, I should be able to catch all of the points. The highest being 98, we can see that that's all the way up there. Now, what do you think what do you think I'm going to ask you? Like, what's the conclusion, even by looking at the data points here? Do I have a strong relationship with those two, Jamie? No, this is a no correlation. Like, that's an example of simply a no. Like, I don't see a negative or a strong positive, and none of that stuff. But we still want to see what the best line of fit would be, and so we can't really measure that accurately quantitatively, other than the fact that we got to go to stat, calc, linear regression. We're still going to use that, and we're going to store the regression equation into. Oh, that's not what I want. Variables, y variables function y sub 1, and then press calculate. Look at the R value. That is really being close to being 0, okay? And my equation, okay, that's what I get. That's the best line of fit that goes through the middle of those data points. Notice how it's like pretty flat. That just means that there's going to be no relationship here. And as you can clearly see from the linear regression data, sorry, I got to keep on doing this again. The R value is what you really want to pay attention to, okay? That negative 0.0, that's being close to being 0. So therefore, we say that there is no relationship, no correlations with this whatsoever. And besides, I mean, look at the quantity. I mean, look at the variables, number of miles, houses from school, and test scores. They really don't have anything to do with each other. Just because you live far away doesn't mean your test score is going to decrease. So there we go. That is what I wanted you guys to get. And please practice using the calculator for today's homework. I'm going to give you tables and make sure you guys get the linear regression model and things like that. That's it for today, and I will see you guys on Wednesday. We have 6 minutes left, so just relax for 5 minutes, and I'll dismiss you guys. Those of you on Zoom, you guys may log off. Have a good day, and I'll see you guys Wednesday.
And then it was submitted by tennis. My birthday tennis day. If you post your number, my birthday. Yeah, like people have like OCD. I got with this. Yeah. Really? Yeah. And then it was talking about all day. Oh yeah, that's a YouTube. Oh my god. Did you register yet? I don't know. I didn't do the work at like 10 o'clock at night. I feel like 18, like their science section. I did so well in 18. My science was I did really well in 18. Like the practice one. Just not. I went about this one. This month I was like, they were pretty good. I was on the phone. I feel like this one was like she was like yeah, no, my first test I was very much and I noticed all these things.
Literally a minute before it's too late. He's like, well, by now it's too late. And I already did like 6 lines. We're being graded like our no, I just wrote. Yeah, I only had to write 4 characters. I couldn't write them. What do you mean? We couldn't read these drafts. Did not do that.
I don't know who it is actually. Are you getting one on one? I'm not doing like. I'm not gonna.
Wait, 12 citations are covered too.
I use my podcast and then myself. Yeah. I don't do it every day. I put
I was over 8 pages before I even started this.
All right, you guys are good to go.